Hello everyone, welcome to the Bodhi Academy. In today's PYQ series, we are going to solve PYQs of 12th Physics, chapter Electromagnetic Induction. So let's solve the first question. Two coils can be arranged in three different situations, A, B and C. So in which situation their mutual inductance be maximum and why? So the mutual inductance is maximum when the two coils are coaxial and placed close to one another as in situation A. So in this position the magnetic flux produced will be produced by one coil links with the another coil and the number of turns in the another coil producing the largest flux linkage, and hence the mutual inductance will be largest in the situation A. When the magnetic flux linked with a coil changes from 2 Weber to 10 Weber in 0.25 seconds, find the average induced EMF. So according to Faraday's law, E equal to change in flux upon change in time. So 10 minus 2, 8 upon 0.25, we will get the answer as 32 volts. Let's move on to the next question. The figure shows a metal ring and a straight current carrying conductor. State the direction of the induced current in the metal ring when the current I in the wires is steadily decreasing, and why is the current induced in the metal ring. So when the current I in the straight wire is decreasing, the magnetic field through the ring due to the wire is decreasing. By using Lenz's law, we can say that the ring induces a current that rises and maintains the original magnetic flux. That is, it produces a magnetic field as in the same direction that is decreasing. Viewed from the above wire, this induced current will be in the anti-clockwise direction. And moving on to the next question, why is the current induced in the metal ring? The current is induced because of the change in the magnetic flux through the ring. That is according to Faraday's law. Let's move on to the next question. A circular coil of radius 8 cm and 20 turns is rotated about its vertical diameter of 120 rpm in a uniform horizontal magnetic field of 0.03 Tesla. Calculate the maximum and RMS values of the induced EMF. So given R radius 0.08 meter and number of turns is 20, B equal to 0.03 Tesla and the rotational speed is 120 rpm rounds per meter. Area of the given coil can be calculated using the formula A equal to pi r square. So A equal to pi r is 0.08 meters the whole square. So we'll get the value as 0.0064 pi meter square. So the rotational speed in hertz can be calculated as F equal to 120 upon 60 seconds per minute. So the answer will be 2 hertz. So the angular frequency omega is 2 pi F. So we'll get the value of omega as omega equal to 2 pi into 2, that will be 4 pi radians per second. So maximum induced EMF will be calculated using the formula Emax equal to NBA omega. So Emax equal to, substituting the value of NBA and omega, 20 multiplied by 0.03 multiplied by 0.064 pi multiplied by 4 pi will get the value as around 0.152 approximately. And to calculate the value of RMS induced, we'll get it as ERMS, root mean square value of the EMF, equal to Emax upon root 2. So we'll get the value as 0.152 upon root 2. That will be around 0.107 volts. Let's move on to the next question. The pedals of a bicycle are attached to a 50 turns coil of area 0.1 meter square. The coil rotates at half a revolution per second and is placed in uniform magnetic field of 0.01 T Tesla, perpendicular to the axis of rotation of the coil. What is the maximum voltage generated in the coil? So we have n equal to 50, area equal to 0.1 meter square, f equal to 0.5 hertz. So B will be 1 into 10 raised to minus 2 Tesla. So omega angular frequency will be 2 pi f. So 3.14 will be the answer. So E equal to NBA omega. So substituting the values of NBA and omega, 50 multiplied by 1 multiplied by 10 raised to minus 1 multiplied by 1 multiplied by 10 raised to minus 2 multiplied by 3.14, we'll get the answer as 15.7 into 10 raised to minus 2. So rounding up, we'll get the value as 0.15 volts. Coming to the next question, two circular currents carrying coils of radii 3 cm and 6 cm have equal magnetic moments. Find the ratio of the currents passing through the coils. So we have radius of first coil as 3 and radius of second coil as 2 cm. The magnetic moments of both the coils are same. So M1 equal to M2. So I1 A1 will be equal to I2 A2. So I1 area will be pi R1 square equal to I2 area of the second coil will be pi R2 square. So 9 into 10 raised to minus 4 I1 equal to 36 into 10 raised to minus 4 I2. So 10 raised to minus 4 and 10 raised to minus 4 will get cancelled. I1 upon I2 equal to 36 upon 9. So I1 upon I2 will be equal to 4. Done. Coming to the next question, an armature coil consists of 20 turns of a wire, each of area 0.1 meter square, and total resistance of 25.0 ohms. It rotates in a magnetic field of 0.5 Tesla at a constant frequency of 150 by pi hertz. Calculate the value of maximum EMF, maximum induced EMF produced in the coil and average induced EMF produced into the coil. So given n equal to 20, area is 0.1 meter square, R is 20, resistance is 25 ohms, B equal to 0.5 Tesla, F equal to 150 by pi hertz. So the maximum induced EMF will be Emax equal to the same formula NBA omega. We don't know what is omega, so we'll take it as 2 pi F. So substituting the value of F from here, 150 by pi, N is 20, B is 0.1 and A is 0.5. Pi will get cancelled and calculating all this will get the value as 300 volts. Average induced EMF produced in the coil is 0. A current is induced in a coil when it is moved in a magnetic field. The direction of the induced current depends on A. The direction of magnetic field only, the direction or B. The direction of motion of the coil only, C. Both direction of magnetic and direction of motion and magnetic field, and D. The magnitude of the magnetic field. So the answer is C, both the direction of motion and magnetic field. By using Fleming's right hand rule, we can make out that the direction of induced current depends on the relative direction of the motion of the conductor and the magnetic field. Coming to the next question, a stiff wire is bent into a semicircle of radius 1 by pi meter as shown in the figure. So, it is rotated about its axis, about its diameter with 30 revolutions per second in a uniform magnetic field of 20 into 10 raised to minus 3 Tesla. Calculate the value of maximum value of EMF induced in the loop. So we are given n equal to 1, r radius 1 upon pi, omega 2 pi v. So for a semicircle, area is pi by 2, 1 upon pi the whole square. So we'll calculate the value of E max equal to NAB omega. So 1 into pi by 2, 1 pi the whole square multiplied by 20 into 10 raised to minus 3 multiplied by 2 pi multiplied by 30. So this pi will get cancelled with this one and the other one, and we'll get the value at as 600 into 10 raised to minus 3. So we'll get the value as 0.6 volts. Let's move on to the next question. This figure shows a magnet moving towards a coil. What will be the direction of the current induced into the coil? What will be the direction of the induced current if the magnet passes through and continues to move away from on the other side of the coil? So the direction of the current induced into the coil will be in the anti-clockwise direction for an observer looking from outside the plane of the paper. And the current will move in the clockwise direction if it continues to move through the coil. That's it for today's PYQ video. Don't forget to like, share and subscribe to the Bodhi Academy. Thank you.